Hello, my name is Roy Simpson. I'm a professor of mathematics at Cosumnes River College in Sacramento, California. This is the last part of a lecture on slope for linear equations. And so therefore we're going to focus on part D here, understanding the meaning of slope in word problems. This is, as I've stated several times throughout this lecture, the most important part of this lecture series. Now, before I begin actually doing examples, I'd like to kind of define something really quickly. A rate of change. Rate of change is something that you'll hear quite a bit in mathematics and also in physics, actually. And it really discusses kind of the change in one quantity versus the change in another quantity. So, a couple brief examples here. For example, my car gets 58 miles whenever I burn up 1 gallon. 58 miles per 1 gallon. That is a rate of change. Your wage might be $22 per, let's say, 1.5 hours. It doesn't have to always be per 1 hour or per 1 gallon. It could be comparison of two quantities where they're both not one. You could say that in a certain square mile there are 37 rabbits per 3 foxes. By the way, that does not mean that there are 37 rabbits and only 3 foxes. It could be that there are twice this many rabbits, therefore there are twice that many foxes, right? So there would be 74 rabbits and 6 foxes. But it gives you a rate or a comparison between these quantities. Now, one last item I want to talk about before we get into some applications, because I really think that this is super important. If you have a situation that can be described graphically, and most situations in mathematics can, actually most situations in real life can, you should really pay attention to the units for the axes. For example, if this axis is R and it stands for rabbits, and this axis is F and it stands for foxes, and somebody were to graph the relationship between the number of rabbits and the number of foxes, and it looks like this, let's just pretend it's supposed to be a line, then if I were to ask you to describe what this slope means, it means the number of foxes to the number of rabbits is increasing, or the slope, the units of the slope, I suppose is a better way to say it, is foxes per rabbit, or per number of rabbits if you want. And this gives us a great idea of a relationship between these two quantities, these two units. So notice that slope is rise over run. Oops. Rise over run. The rise variable is foxes. The run variable is rabbits. And that's very important because, again, it leads to an interpretation. So it allows you to really tell somebody what the meaning of a slope for a situation is. Somebody could say, well, here's a graph of a line, and it's a linear equation, and it describes some relationship between foxes and rabbits. And you could say, oh, that means, let's say the slope of this was 3, I forget what I had as the previous number, 3 and 37. Let's say the slope of that line is 3/37. Well, we know the rise has to deal with foxes and the run has to deal with rabbits, so it's 3 foxes for every 37 rabbits. That's what the slope is telling us. We have 3 foxes for every 37 rabbits. Along the same lines, let's say you're driving and you're burning gas in your car. Okay? And so let's let this axis right here be M, and that's just the number of miles that you've driven. And this will be our g-axis. This will be the number of gallons that you've burned. So, you can burn 1 gallon or 2 gallons or 3 gallons and so on and so forth. And let's suppose this number is 58 and this number is 116 and so on and so forth. So you have some type of graph here. And somebody asks you, one, to calculate the slope of that line. Well, this is the point 2, 116. This point right here is 1, 58. So computing the slope is pretty easy in this situation. The slope would be, well, the difference in y values, right? 116 minus 58 over the difference in the corresponding x values, 2 minus 1. If you do the math, that's 58 over 1. And there are units on this. The units for the vertical variable, the m variable, is miles. The units for the horizontal variable are gallons. And so if you want to interpret the meaning of the slope, it means you get 58 miles per 1 gallon, or basically per gallon. So not only do you get a numerical answer, but you get an interpretation, 58 miles per gallon. So this means your car gets 58 miles a gallon. So then let's actually try some nice setup examples. So the table below shows the amount of ammonium chloride salt in grams that can be dissolved in 100 grams of water at different temperatures. So we can have 33 grams of salt dissolve in 100 grams of water when the temperature is 10 degrees Celsius. And as the temperature increases, we can dissolve more salt. So this is sort of like you're boiling off the salt. So once the temperature increases to 52 degrees centigrade or Celsius, you can burn off a lot of salt, 54 grams of salt. And this is in 100 grams of water. That's the constant here. Now the question, there are two sub-questions. If you plot the data, will the points lie on a straight line? And why or why not? That's kind of an important question. I really like this question. So let's go ahead and kind of relabel this table of data. I have temperature and I have grams of salt. When the temperature is 10, we can burn off 33 grams of salt. When the temperature is 12, we can burn off 34 grams of salt. When the temperature is 15, we can burn off 35.5 grams of salt, and so on and so forth. So let me just finish writing these out really quickly. 38.5 and 25. While I'm writing these out, you should be really thinking about how we're going to approach this. In fact, a good piece of advice, every time you watch a lecture online, doesn't matter if it's my lectures or somebody else's, you should always be thinking ahead. Try to think about how a problem is going to be done. We know something about lines, that they have constant slope. So if all these points lie on the same line, then every time that I increment by amounts, the slope between these points should be the same. In other words, if I calculate the slope between this first and second point, it should be the same as calculating the slope between the second and the third, and the third and the fourth, and the fourth and the fifth, and the fifth and sixth, and so on and so forth. So that's how we're going to determine if all of these points lie on a line. Okay, so let's go ahead and calculate the slope using the first 2 points. So it'll be y value minus y value over corresponding x value minus corresponding x value. And what is that? A negative 1 over a negative 2, or in other words, 1/2. Okay, so it tells me the slope here is 1/2 between these 2 points. Now remember, that's rise over run. Probably a good way to think about this, well, maybe I'll do one more example here and then I'll kind of give you the hint. Let's do the next 2 points. So 12, 34 and 15, 35.5. The difference in the y values is 34 minus 35.5 divided by the difference in x values, which is 12 minus 15. That's 1.5 with a negative in front of it. So negative 1.5 over a negative 3, and that turns out to be another half. So the slope is the same. That's not enough to show that all these points lie on the same line, but there's a trick you could do. This tells me that every time that I run 2 steps, I rise 1. Well, that's pretty cool. But if that means, so if you look at this, if I run 2 steps, I would rise 1, let's just say. Let's just say the data looks something like this. Well, that means if I only run 1 step, how far up do I go? Do I go up a full 1? Well, I should only go up half that amount. So let me write that. In other words, each step forward, maybe I'll pause this. Each step forward of 1 increases the output by 1/2. Now this is the slope addition property. Once we know the slope, we know that every step of 1 gives us the slope. We add the slope to our values. So if we start at an input of 10, where is my cursor? There it is. If I start at an input of 10 and I step to the number 11, I know I'll be at 33.5. And if I take another step from 11 to 12, I should be 33.5 plus an extra half, or 34. Aha. And if I take another 3 steps, I should go through 34.5 to 35 to 35.5. Aha. So that was 3 steps. Let me write that in a little bit better. That's 3 steps. So that should be 3 sets of 1/2s I'm adding to that 34. Remember, each single step adds a 1/2, so 3 steps would add 3 of those halves. And look at the next set of steps. From 15 to 21, I'm doing 6 steps, which means that my output should increase by 6 sets of those 1/2s. Well, 6 times 1/2 is 3, so it should increase by 3, and lo and behold, it does increase by 3. So that's good. The next, from 21 to 25, is 4 steps. Well, that should increase by 4 sets of halves, or in other words, 4 times a half is 2. So I should step forward by 2. And look, 38.5 plus 2 is 40.5. So I'm using that slope addition property that I mentioned in the last lecture, that if you know you step by 1, then your output increases by the slope. Here my step is increasing by 15. So that means that my output should change by 15 of those halves. Well, that's 15.5, or 7.5. Well, if you add 7.5 to 40.5, it'll actually get you to 48. So that's right. And finally, the next group of steps is by 12, right? So that's 12 steps right there. And 12 times a half is 6, so add 6 to that 48, that's 54. Yes, each of these points is on a line. So it's on the same line, actually. So yes, and the reason why is because each of them increases by the same slope. Maybe I'll write that down. Each increases by the same amount over a single step, or in other words, they each have the same slope connecting to them. So they all will land on the same line. It says calculate the rate of change of salt dissolved with respect to temperature. The rate of change of salt with respect to temperature. And include units in your answer. Well, remember what I said about rate of change. It's a change in one quantity over another. And this is saying the rate of change of salt with respect to temperature. When somebody says salt with respect to temperature, or miles with respect to gallons, or quantity 1 with respect to quantity 2, with respect, and by the way, mathematicians write this phrase with respect to so much that they just use WRT. But if they say calculate quantity 1 with respect to quantity 2, that means you want to find out what quantity 1 divided by quantity 2 is actually going to be. So in our question, we were asked to calculate the rate of change of salt dissolved with respect to temperature. Well, that means you want to find out how many grams of salt get dissolved per degree Celsius. Increase or decrease? Well, rate of change is going to be the slope, and we already know the slope of this is 1/2. So that means that we dissolve 1 gram of salt per 2-degree increase in degrees Celsius. So implies an increase of dissolving. I'm not sure if I'm going to spell dissolving right, so let me just double check how you spell that. Yeah, 2 S's. See, I'm a mathematician. An increase of dissolving 1 gram of salt per 2 degrees Celsius increase. So when you tell that to somebody, they should know that, oh, if you increase the temperature by 2 degrees Celsius, you will dissolve another gram of salt. Okay? So that's using units and kind of understanding the units of slope. Now, just to nail this down a little bit better, we'll do one more example here. The graph below shows the amount of water remaining in liters in a Southern California household T days after an earthquake. And so let me go ahead and I'm just going to make this up. This is not real data. I'm just going to go ahead and make up something. Now, I absolutely made up this graph. This is not true, but let's just suppose that you have this information. I'm going to tack on an extra little bit. Let's tack on a part A sub 0. What are the intercepts and what is the meaning? What are intercepts and what do they mean? That's a very important question to ask, and you should be trying to answer that right now. Maybe pause the video or something like that to answer that question. Now the intercepts here, well, let's see. The vertical axis represents the amount of water we have in liters. And T is the number of days that have passed since this earthquake occurred. So obviously some pipeline is broken and all civilization has died off, and so now they're just surviving on what they had. The intercepts here, so let's answer A sub 0. The intercepts occur at T equals 0, W equals 500. And then the other intercept way down here is at T equals 50, but W is 0. Remember, the intercepts occur on the axes, and on the axis, on each axis, one of the values is going to be 0. But what is the meaning of these intercepts? Well, that first intercept right there at T equals 0, 500 means that, well, on the day that the earthquake struck, they had 500 liters of water. So day 0, they had 500 liters of water. It might be a family or something like that. Okay, I'm just going to abbreviate water there. And the second intercept, the horizontal intercept, which occurs at 50, 0, means that in 50 days, they'll have no water. Very important. If you don't know how to interpret intercepts and somebody shows you this graph, I mean, I'm not saying that you couldn't do this, but the fact is if you couldn't do this and somebody were to say, here's a graph of your water situation, interpret it, I'm going to run around and help other people during this earthquake situation. If you couldn't interpret this, then you'd probably run out of water, right? Well, you probably wouldn't. You'd probably figure it out, but whatever. Okay, the second part of this is asking us to compute the slope of this graph. So let's go ahead and do that. I have a couple points. I could do that. So the slope is the difference in the y values, remember, over the corresponding difference in the x values. So remember the first y value I chose was the 500, so first x value has to be the 0 associated with it. And then the second x value is 50. So we have 500 over a negative 50, which is going to be a negative 10. All right. Negative 10 what? What does that mean? Interpret the meaning of this, and that's part B. Interpret the meaning of this in this situation. Well, attach units to that. It means negative 10 rise over run. The rise variable's liters of water per, and then the run variable, the horizontal variable, is number of days. So negative 10 liters of water per day, or in other words, you lose or drink 10 liters of water per day. All right, that's a very important piece of information. So I like the fact that if your instructor asks you these questions or asks you to interpret using problems like these, it'll really prepare you for college level mathematics, especially once you get into calculus, where you really have to understand the units for a situation, because it has to become second nature after a while.